Welcome back to the online student. Today we're going to be looking at the determinant of a 3x3 and n/n matrix. In this video I'm going to be teaching you how to calculate the determinant of a 3x3. Then we're going to be looking at an example. Afterwards we're going to calculate the determinant of a n/n matrix, and then we're going to be looking at a second example. We start off by looking at the definition. The determinant of a 3x3 matrix is equal to the sum of every element of a row or column multiplied with its cofactor. But you might be wondering, what is a cofactor? Well, the cofactor is the determinant of the matrix after deleting the row and the column of this element, and we multiply it with -1 to the power of I plus j, where I represents the number of the row and j represents the number of the column. Let's look at a quick example. We want to find the cofactor of this first element too. Well, we delete the row and we delete the column, and we calculate the determinant of what is left. And we multiply it with -1 to the power of I plus j. Our element is on the first row and first column, so this is 1 plus 1. Now all we have to do is simplify this, so this is equal to 1, and the determinant of this 2x2 matrix is equal to 0 times 7 minus 5 times 2. This is of course equal to -10, and this is the cofactor of our first element. Before watching this video, I strongly recommend watching my previous video on the determinant of a 2x2 matrix. Let's go back to our definition real quick. We have to take the sum of every element of a row or column multiplied with its cofactor. It does not matter which row or column you use, as long as you take the sum of every element multiplied with its cofactor. Let's have a look at an example. We have this determinant. Let's say we choose our first row to define our determinant. Well, the first element is 2. We have to multiply each element with its cofactor. The cofactor of this element, we delete the row and we delete the column, and now we have the determinant of what is left, which is 0 times 7 minus 5 times 2. And of course we have to multiply it with -1 to the power of row plus column. And the first element is on our first row and first column. Okay, now we move on to the next element. Next element is 3. So we add 3, but we have to multiply it with its cofactor. Okay, so we delete the row and we delete the column. And now we have to calculate the determinant of what's left. The determinant of what's left is 4 times 7 minus 6 times 2. And of course we have to multiply it with -1 to the power of row plus column. This time it's the first row and the second column, so 1 plus 2. So this will be negative. Then we move on to our last element. Our last element is -1. So we add -1 and we multiply it with its cofactor. So we delete the row and we delete the column, and we determine the determinant of what's left. In this case it's 4 times 5 minus -6 times 0. Of course we multiply again with -1 to the power of row plus column, which in this case is the first row and the third column, so 1 plus 3. Now all we have to do is simplify this, so the first line is equal to 2 times -10, so this is -20. Second line is equal to 3 times -40, so this is equal to -120. And the last line is equal to -20 again. Of course, this is equal to -160, and this is the determinant of our 3x3 matrix. Now there is something you should know. You should always choose a row or column with the most zeros in it. Let's say we took this second row. Then our second element would be 0. So this orange number would be 0, and then this whole line is 0. So this makes it really easy. Now let's have a look at a determinant of a n/n matrix where n is greater than 3. The determinant of a n/n matrix is equal to the sum of every element of a row or column multiplied with its cofactor. As you can tell, it is exactly the same method. But keep in mind, choose the row or column with the most amount of zeros, because it makes it really easy. Let's put it to the test. We have this 4x4 matrix. As you can tell, the third column has 3 zeros in it, so we'll choose this one. Okay, our first element is 0. So we have to multiply it with its cofactor. But we know that multiplying 0 with something will be 0 anyway. so we can just write 0 and move on to the next element. The next element is 0 again, so we can just add 0 and move on to the next element. The next element is equal to 2, so we have to add 2 and multiply it with its cofactor. To find the cofactor, we delete a row and we delete a column. We multiply it with -1 times row and column. This time it's the second row and third column, so 2 plus 3. And then we multiply it with the determinant of what's left. Our last element is once again equal to 0, so we can just add 0. Now all we have to do is simplify this, so we have 2 times -1 times the determinant of this 3x3 matrix. We use exactly the same method. So we see that in our first column we have 2 zeros, so we'll choose this one. The first element is 1, so we write 1 and we multiply it with its cofactor. So we delete the row and we delete the column, and we multiply it with -1 to the power of first row, first column, times the determinant of what's left, which in this case is 1 times 4 minus 8 times 7. We can simplify this and our total is equal to 104. And this is the solution to our second example. This brings us to the end. Please consider subscribing and I'll see you in the next video.